Welcome everyone. Today, we're going to make Ohm's law simple and easy to understand. Our slide is titled, Ohm's Law Made Simple, and we'll explore a handy triangle trick that makes solving for voltage, current, and resistance straightforward. We'll cover how the formula V equals I times R works, and how to use it quickly and confidently. So, let's get started and discover how this simple trick can help you master Ohm's law with ease. Let's take a closer look at Ohm's law, which is the fundamental relationship that links three key electrical properties: voltage, current, and resistance. The formula is simple but powerful. V equals I times R. Now, what does that really mean? Well, it means that voltage, or V, is the product of current, I, and resistance, R. Think of it like water flowing through a pipe. The voltage is like the water pressure pushing the water through the pipe. The current is how much water is actually flowing, and resistance is how narrow or broad the pipe is. So if you increase the pressure, that is the voltage, while keeping the pipe the same size or resistance, more water will flow, which means the current increases. Conversely, if the pipe becomes narrower or the resistance increases, then less water or current gets through at the same pressure. This core formula is essential because it helps us understand how changing one property affects the others. It's like a foundation for all our later discussions about circuit behavior. Remember, understanding this relationship is key to mastering how electrical systems work. All right, let's take a closer look at Ohm's law and the three key variables involved. First up is resistance. Represented by R. Resistance is essentially how much a material opposes the flow of current. Think of it like a narrow pipe that makes it harder for water to pass through. Next, we have current. Denoted by I. Current is the flow of electric charge, similar to how water flows through a pipe. The greater the current, the more charge is moving through the circuit. And finally, voltage, which is V. Voltage is the electric potential difference, or the push that drives the current through the resistance. You can imagine it like the pressure in a water pipe that pushes the water along. These three variables are interconnected, and understanding their relationship helps us control and predict how electrical circuits behave. When we manipulate one, the others respond according to Ohm's law, which is the foundation of everything we're exploring here. Let's walk through some simple calculations using Ohm's law. First, we have the step to determine resistance. The formula is R equals V divided by I, for example. If a circuit has 9 volts and carries 3 amps of current, we divide 9 by 3 and find that the resistance is 3 ohms. Next, we look at how to find current. The key formula here is I equals V divided by R. Say you have 12 volts across a 4 ohm resistor. Dividing 12 by 4 gives us 3 amps flowing through the circuit. Finally, to calculate voltage, we use V equals I times R. Imagine a circuit with 2 amps flowing through 5 ohms of resistance. Multiplying 2 by 5 gives us 10 volts. These calculations are fundamental because they help us understand the relationship between voltage, current, and resistance. They're the building blocks for practical applications in electrical systems. Remember, by mastering these simple formulas, you can troubleshoot, design, and analyze circuits more effectively. Ohm's law made simple. The triangle trick makes it really easy to understand and remember how voltage, current, and resistance are related. Remember, V equals I times R. This means that if you know any two of these values, you can easily find the third. It's a handy shortcut for solving circuit problems without getting lost in complicated calculations. The key takeaway here is that Ohm's law is a fundamental tool in understanding how electrical circuits work, and mastering this triangle trick helps make the whole process much more intuitive. So, keep this in mind as your go-to method for quick calculations and deeper circuit understanding.